If the thumbnail looks like a CD to you, yeah, I see it too. Silicon wafers don't have holes in the middle. Our image generator is deeply confused. Anyway, you're watching this on sand. I don't mean that in a poetic way. The chip inside your phone, your laptop, the server this video lives on. Sand, melted down, cleaned up, sliced into thin wafers, and carved with billions of tiny switches. The second most common element in the dirt under your feet became the brain of every machine on Earth. And the wild part? The whole trick is adding the wrong atoms on purpose. Silicon is element 14. It makes up about 28% of the Earth's crust by weight. Only oxygen beats it. You've walked on it, you've looked through it, you've built castles out of it at the beach. Sand is mostly silicon and oxygen stuck together. So is quartz, so is glass. Glass is just what happens when you heat that stuff until it forgets how to be a crystal. Also, real silicon wafers are round, not square. You slice a cylinder, you get circles geometry. Pure silicon is a blue-gray solid. Shiny, hard snaps, if you bend it, looks like a metal but isn't one. It's what we call a semiconductor. It carries electricity but badly on purpose. And that badly on purpose part is the whole story of modern computing. Here's where it gets weird. Pure silicon is almost useless for chips, too clean, electrons can't move through it well enough, so engineers add tiny amounts of other elements. This is called doping, and yes, that's the real name. You add atoms that don't quite fit on purpose, that's the trick. Add a little bit of the element phosphorus, it brings one extra electron along. Now you've got loose electrons floating around, that's called N-type. Add boron instead. Boron is one electron short. It leaves little gaps like empty seats. That's P-type. Put the two types next to each other and electrons flow in one direction. That's a switch. Stack billions of those switches and you get the thing in your pocket that can run a calculator and show you cat videos. Making silicon pure enough starts with beach sand. Seriously, sand goes into a furnace at about 1,800 degrees with carbon that rips the oxygen off. Then it gets cleaned again and again until it's 99.999999% pure. That's 9 nines. Your tap water has more variety. Then comes a step called the Czochralski process. Here's how it works. A tiny crystal seed dips into a pool of melted silicon, then a machine pulls it up. Slowly, a huge rod of perfect crystal grows out of the pool. These rods can be a foot wide. They get sliced into thin, round wafers. Each wafer holds hundreds of chips. This is an industrial substance, the stuff that built the age of computers. Oh, and glass, same atoms, silicon and oxygen, but glass is a mess on the inside. The atoms aren't lined up in a neat grid. They're frozen in a jumble. Like if you took a deck of cards and just dropped it, that's glass. Same recipe as quartz, totally different result. Quick note on what you're seeing. That's a circuit board, not a chip surface. At 3 nanometers, you'd need an electron microscope. The real thing looks like a satellite photo of a very tiny, very organized city. The newest chips have features about 3 billionths of a meter wide. That's roughly 15 silicon atoms across, and we're hitting a wall. At that size, electrons start doing something wild. They walk through walls. Literally, it's called quantum tunneling. The electron just shows up on the other side of a barrier. It had no business crossing, like a ball rolling through a brick wall. Physics stops caring about your switch design at that point. The chip industry is spending billions trying to keep shrinking. New light sources, new switch shapes, new materials stacked on top of silicon, but the base layer is still silicon. It's been silicon since the 1960s. 60 years, one material. And here's the part nobody talks about. Making chips is one of the dirtiest clean jobs on Earth. A single chip factory uses millions of gallons of super pure water per day. The chemicals involved, acids, solvents, dozens of them. The waste needs careful handling. The carbon cost of making one chip is measured in kilograms of CO2. For a piece of silicon the size of your thumbnail. Silicon Valley isn't named after money, it's named after this element. The valley south of San Francisco, where the first big chip companies set up shop in the 1960s, they picked the name because the material was the point, one element cleaned to crazy purity, mixed with the wrong atoms on purpose and sliced thin. That's the whole revolution. Every text you send, every search you run, every photo you take, it all passes through a piece of sand that somebody spent a week purifying and a machine spent a month etching. One atom everywhere. I'm Kaito. If you want more molecules that quietly run the world, subscribe. I'll be back with another one, assuming my silicon doesn't tunnel somewhere it shouldn't.